Hello everyone, welcome to Wave Optics and Semiconductor Physics course. Today we are going to discuss about Young's double slit experiment. So if you see Young's double slit experiment, one source and it is divided into two sources, that means secondary sources. When the waves superimpose and produce alternative bright and dark fringes. So this is what Young's double slit experiment. Let's see in brief. So one source, if you pass through two sources, sets S1 and S2. These two are acting like a secondary sources and produce bright, dark, bright, dark, bright, dark fringes like this. So this is what is called Young's double slit experiment. So that's what Young was observed. But here, the important thing is that why this alternative bright, dark will come? Because practically, if you take two bulbs or two torch lights with having the same power, that means then if you focus these two torches at a one point on a screen, let's say in a wall, in a room, you take two torch lights and focus at one point, then what will happen? For example, this one torch light is focused here, and this one torch light is focusing here. Let's say the intensity of this thing is like amplitude is a, so intensity is a square, let's say, and this intensity is you take it is a square. And now these two torches are similar torch, identical torch lights, so same intensity will be there. Now when these two lights focused on a screen, then obviously this intensity is getting added up. It should be 2a square that we can see in a home at home. So just on a wall, you can observe some area of the screen. It is more light is there because of two torch lights. That means two intensities of the light get added up. So at every point, whatever the point you take on the screen on the wall, that intensity is always equivalent to the 2a square. So equal intensity will be there. At some particular center portion, you take 2a square. So this is what we practically can observe. But Young, he was observed that whenever you keep two sources at a distance in millimeters, and if you place a screen in meters distance, then if you take coherent sources with having same amplitude, same frequency, and same wavelength, then you can observe that bright, dark, bright, dark, bright, dark, like this alternative pattern. It's really amazing because it doesn't happen in every time. It happens only under these circumstances only. So from this, everyone has turned and the light phenomena. Earlier, it is believed that light is a particle nature. Once if it is a particle nature, this cannot happen. So the wave nature of light has taken considered and explained. So why this bright is coming? Why bright is coming? So when if you take a wave nature, the bright is because of the two waves are in the same phase at meeting at this point, bright point. So that's why it is coming high intensity according to superposition principle. The intensity is here will become 4a square because a plus a whole square, 2a whole square is the intensity, 4a square. Whenever these two are in opposite phase, according to superposition principle, so it is, for example, as you remember, superposition principle, the resultant amplitude is a is equal to square root of a1 square plus a2 square plus 2a1 a2 2a1 a2 cos phi. So here amplitudes are both are equal. So these two are equal. So resultant amplitude, let's say capital A. So now for first case, this case, two amplitudes are equal. That means a square plus a square. This means 2a square. That means 4a square. And cos phi, here both are in same phase means cos phi is 1. So the square root of 4a square means it is 2a. So that intensity is 4a square because intensity is equal to square of the amplitude. It is 4a square. Whereas in case of here dark, here opposite phase means cos phi is equal to cos phi is 180, phi is 180, cos phi means minus will come. That means here 2a square minus here 2a square will come. That means amplitude for the dark case, it is 0. That means intensity becomes 0. That means this intensity becomes 0. So intensity of light is 0 means there is no light. Then it is violating the law of conservation of energy. And here it is again bright means here same phase 4a square will come. Here 0, 4a square is come like this. So and 0 like this it is coming. So simply by looking here, it is violating, it look like it is violating law of conservation of energy. But actually, if you think, if you forgot about superposition principle, whenever two light sources are having same amplitudes A and A, then on the screen, what we are expecting the, if you forgot about superposition principle, so when these two light sources are meeting here, that means the resultant intensity should be 2a square. That means here, this point is 2a square. This point should be 2a square. Everywhere it is 2a square. That's what we can see on the screen. We can observe. And 2a square like this, it should happen in normal cases. But if you arrange like this, then what will happen? This 2a square is getting added up to the this here, so that it becomes 4a square, it becomes 0. Again, this 2a square is added up here, and this becomes 0, this 4a square. So that the energy is getting conserved here by just adding this intensity to the top one. So like this alternative bright and dark and fringes you can observe. So this is most surprisingly, so the Youngs observed this is most surprising part, that this having the one particular pattern, the nature following the particular pattern. That's what everyone should try to impress upon this. And now, how this happens? Because of this, the phases of the when they are meeting at that point, the phases, how the phases are there based on the bright and dark is coming. Now, how to decide this one? Bright, whether it is bright or dark. That decides based on the path difference. Because once you know the path difference, we can measure the phase difference. So how the phases are changing, that we don't know. But if we can measure the path difference, and as we know, phase difference is equal delta is equal to 2 pi by lambda into path difference is delta. This is from this relation. If you can measure the path difference, you can measure the phase difference. From this, we can expect what is coming here, whether it is bright or dark. How we can find bright or dark? Let's see this example. So before that, as we know that if you want to prepare, want to come bright, there is a condition is that path reference should be L lambda. That means path reference should be either, so delta is equal to, either if you take 0, n is equal to 0 means if delta is equal to 0, then we can say it is a bright. For example, if you take 1, then it is lambda. If delta path difference, if you measure path difference, it is delta, then it is also bright. If you get 2 lambda, that is also bright condition. These are the bright condition. For dark, what is the condition? Path difference is equal to, if you place n is equal to 0 here, that means what will come? Lambda by 2 will come. So if you measure the path difference, if the path difference is lambda by 2, then you can say there is a dark is forming there at that point. And here also it is at 3 lambda by 2. If you take n is equal to 1, 5 lambda by 2, like this, these are the conditions. So keeping this in our mind, that now let's see the points from the source, the wave is coming, reaching here, and wave is reaching here at this point. So what is the path difference? Path difference means you have to find this length in terms of wavelength. So how many waves are there here? One. This is one wave. 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 waves are there. So wavelength, if you take lambda, then this L1 is equal to 10 lambda. It is 10 lambda. And now again, it is 1 for this wave, wave 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So for this light ray, it is reaching here. This is the distance is 11 lambda. The distance traveled by this light ray is 11 lambda. So then what is the path difference? Path difference means delta. In this case, at this point, what is the path difference? Delta is equal to 11 lambda minus 10 lambda. That means it is coming like lambda. So delta is equal to lambda. So if you we measure the path difference, that is delta is equal to lambda. It is for which condition? It is true for the bright. Delta is equal to lambda means this condition. So that means here bright fringe will form. So like this, we can decide the we can decide at what point bright forms or dark forms. That we can predict by using this example. And similarly, and most importantly, so there is a shortcut method is there. That means unnecessarily you need not find total length. Just if you draw a normal on this, then this length and this length is equal. So these two lengths is equal. Additional length is this one. So how much is the additional length? This is one wavelength, lambda. So path reference is lambda. From this we can predict here bright fringe will form. So this is the one thing. And if you take another thing, another point, this point, anyway, I shown here. Now, if you measure the path reference, directly if you measure path reference, we draw a normal, then this path reference is how much? It is like half of the wave. That means delta is equal to, directly we can write delta is equal to lambda by 2. Delta is equal to lambda by 2 means it is a condition for the dark, because if you keep 0 here, then delta is equal to lambda by 2 is coming. So it is dark. This point you should represent dark. So there dark fringe will form. So like this, we can estimate on a screen whether it is bright or dark, we can estimate. Let's see another example. Here at center point, at this point, what will form? Here, the lengths are equal, because if you draw perpendicular also, what is the path reference? There is nothing is there path reference. That means delta is equal to 0. So delta is equal to 0 means, which is what condition it is? Delta, see, n is equal to 0, you put here. So delta is equal to 0, that is for the bright. That means here bright will form. So like this, we can see what is forming, bright or dark. So that we can see. Now this is Young's double slit experiment. So based on this, I just wanted you to give an assignment of Young double slit experiment. So this data, you don't think this is correct data. So this is for simplicity. I just made this one. This is not exact data. So that you have to keep in your mind. And here, what you have to find, identify maximum intensity points. That means if you say Young double slit experiment, if you take two sources and this is the screen. Now I just wanted to find what is the height of point P2. That means P2 point means that is the first bright fringe. So maximum intensity means first bright fringe. This is the first bright fringe. At what height it forms? So this height you just want to measure the. So for that, what you have to do, you take a A4 sheet. On A4 sheet, so you draw a line like this, 2 centimeter width. So this is 1 and 1 centimeter you take. So then at 10 centimeter distance, at 10 centimeter distance, you take another line, that is you take it as a screen. And now what you have to do, you have to find the P2, where P2 will be there. That means, so here it is a maximum intensity means first maximum is will come, so it is 0, delta is equal to 0 means that is the center one. And next maximum is delta is equal to lambda. Okay. So delta is equal to lambda. Next maximum is delta is equal to 2 lambda. Next one is delta is equal to 3 lambda. Okay. So lambda I've given here, it is, what is lambda here? So this is the condition 2 lambda. Here, just what you have to do, uh, you take, you draw one line, you draw another line. Okay, let's say you draw like this. Sorry, it's not coming good. So you draw a straight line simply from source S1. You for example this line. So another line you draw it. So now by using scale, you can measure what is the length of this one. Something if I say it is like 12 centimeter, 12.3 centimeters has come. Okay. Then this, if you measure, this is 15.1 centimeters has come. Let's see. Now, what is the path difference is here? Then it is like not exactly 3, this means 2.8 centimeters. 2.8 centimeters. That means 1 centimeter is lambda. So the path reference is here. This ideal case in general. Just for example, it is 2.8 lambda. So, but what we need delta is equal to lambda point. So 2.8 lambda means delta is equal to 2.8 means it lies somewhere here. Okay, that point is this point is 2.8 lambda. Let's say, then I just want lambda. That means maybe here it may come lambda, direct lambda will come here. That means if I draw from here to here and another one if I draw here, then this could may come, the difference may be lambda is coming. So this point I can say at this point, path reference is 1 centimeter or lambda. So delta is equal to lambda. So this point is the point where the maximum intensity is coming. So that point I'll fix. This point is P2. This point is P2. Now, what you have to do, you have to measure height. This is, for example, 1.1 centimeter. Let's say 1.1 centimeter that you have to fill here. Okay. So like this, you have to do. So like this P2, you can identify at what height it is there. P4 means delta should be 2 lambda. Where delta should be 2 lambda will come. If it is lambda, something somewhere lies, it may be here. So for this, what you have to do again, measure this length and again measure this length. The difference should come. It is 2 lambda. That means 2 centimeters should come. If it is coming 2 centimeters, then you have to find the height. This height you have to write here. Next, like this, P6. P6 means delta should be 3 lambda. So that's what it is a condition for bright. So what are the conditions for bright? Delta is equal to 0. 0 anyway, center is here. You leave it. Next one is lambda. That means that is P2. Next one is 2 lambda. That means this one P4. Next one is 3 lambda. So that is P6. So those heights you have to find. So lambda here, it is 1 centimeter. That means the length is here. Just simply I am taken, this is lambda from here to here. This is, if I take it is a 1 centimeter, then lambda is equal to 1 centimeter. Okay. Like this, you have to do this assignment. Similarly, you perform the same exercise for the minimum intensity. Minimum intensity is here, means dark condition. This is minimum intensity means dark. For dark condition, what is that lambda delta path difference delta is equal to? It is lambda by 2. First condition is lambda by 2. That means P1 is equal to, that means path difference where it is coming lambda by 2, that is point P1. That means if you draw a line from here to somewhere like this to draw, if I measure the path difference is should be lambda by lambda is 1 centimeter is 0.5. The path difference should come 0.5. So then that point is P1. That means 0.5 centimeters should come. Like that, you have to select one point where 0.5 centimeters should come. Then this height is P1. height. That you have to report here. Similarly, next one is what? P3. Next to condition is lambda by 2. Next, if you take n is equal to 1 means 3 lambda by 2. Next is 5 lambda by 2. 5 lambda by 2. So P3 is 3 lambda by 2. That means 3.5. That means 1.5 centimeters. That means at this point, it could be the path reference. If you measure the path reference, that should come 1.5 centimeters. Then this is the exact point of P3. So this height again you have to give here. Like this, you have to give here P5. So this is the assignment just for your understanding. So don't bother about these values. Okay. Those values are not correct, but okay. Thank you.